Hello. So sometimes it's complicated to figure out which problem to get started with. So you get stuck before you even get to the math because you don't know which law you're dealing with. So that's where this gas law triangle comes in handy. And hopefully after you get done the worksheet, it's a little bit clearer. So if I have pressure and volume changing in the problem, but temperature is constant or unchanging, that's Boyle's law. If I have volume and temperature changing, but pressure is constant and unchanging, then I have Charles's law. If I have pressure and temperature changing in the problem and volume is constant, that's Gay-Lussac's law. And if I have pressure, volume, and temperature changing, that is the combined gas law. Now in all of these problems, moles are constant. We didn't change how many grams or how many moles of the gas that we have. Okay, so the moles are always constant. And then for Boyle's, the temperature is constant. And for Charles, the pressure is constant. And for Gay-Lussac's, the volume is constant. So those are your constants there. How about units? Let's make sure we know what units are what. Pressure units. Millimeters of mercury, torrs, bars, pascals, kilopascals, atmospheres. Those should all be on your front of your notebook for units of pressure. How about volume? Liters, decimeters cubed, centimeters cubed, cc's or centimeters cubed, and milliliters are often the ones that you can use. Obviously, anything with a root of liters is going to be a volume. And temperature, degrees C, degrees F, and Kelvin. Change everything to Kelvin so that you're making sure you're not going to have any conversion answers. So temperature, always change to Kelvin. If you get two pressures or two volumes, change to the same units so that you are comparing apples to apples. All right, so let's get started with the work. What do we know? Number one, 2.0 liters of carbon dioxide is heated from negative 25 degrees C to standard temperature. Now, even though that's not a number, I'm still going to circle it because I know standard temperature is 0 degrees C. What is the final volume? All right, so what are we working with here? Liters, so that's a volume. Negative 25 degrees C, that's a temperature. Standard temperature, that's a temperature. So I have two temperatures and one volume. All right, so when I look on my thing, what did I not talk about? I didn't talk about pressure. So in number one, pressure is going to be constant. I'm only dealing with volume and temperature. So it's Charles's law. What's the formula? V1 over T1 equals V2 over T2. So if you memorize the triangle, then you have that for the SOL. The V is over the T. That's how you can remember the equation. Okay. And now let's substitute. V1 is my first volume, 2 liters. T1, oh, it's not in Kelvin though, negative 25.0 plus 273. And that would be 273 minus 25. That would be 248 Kelvin is my initial temperature or my starting temperature. And make sure you put the units there to make sure you are comparing apples to apples. What is the final volume or the second volume? So that's V2 at standard temperature. 0 degrees plus 273 gives me 273 Kelvin. Okay. So you can solve this any way you want. I'm used to the crisscross or the butterfly method. I multiply and then divide. So 273 times 2 divided by 248 gives me a volume 2 from the calculator, 2.2016129. What is that volume units? Apples to apples. So if I started with liters, I ended with liters. Substitute, solve, Sig Figs, 2 Sig Figs, 3 Sig Figs, Technically, that looks like 1 sig fig, but really standard temperature is at a perfect 0. So if you round to 1 sig fig for this answer, I will still give you credit, but I would prefer that you use 2 sig figs there. So 2.2 liters. All right, let's go on to the next problem. So in this one, what do we know? 1250 centimeters cubed of chlorine gas at 25 degrees C and 90,000 pascals. What volume would the same gas occupy at standard temperature and pressure? STP. All right, so centimeters cubed, that's a volume. 25 degrees C temperature. Pascals, pressure. So I have a pressure, volume, and temperature. What volume, so I'm going to be solving for volume, will the same one occupy at temperature and pressure? So in this case, I have pressure, volume, and temperature on the left, and I have pressure, volume, and temperature on the right. So I need to use the whole triangle. Pressure 1 times volume 1 over temperature 1 equals pressure 2 times volume 2 over temperature 2. The combined gas law. So the only thing constant here is the moles. So now I have to make sure I'm talking apples to apples. So centimeters cubed is fine for the volume. It just means my final volume is going to be centimeters cubed. So make sure you have the right units at the end. Temperature, make sure you convert that to Kelvin. How do we convert to Kelvin? Temperature in Kelvin is equal to degrees C plus 273. All right. And pascals, that's going to be the wrong one. We don't have a number for standard pressure from pascals, but I do know I have standard pressure of 101.3 kilopascals. So I know if I convert my pascals to kilopascals, then I'd be comparing apples to oranges. And my STP temperature is 0 degrees C. Make sure you convert that to Kelvin for your problem. So if I have pascals, that's my known, and I want to convert it to kilopascals. There are 1,000 pascals and 1 kilopascal. So that means they are 90 kilopascals. Okay. So what is that going to be? 90 kilopascals is going to be my pressure 1. 1250 is going to be my volume 1. And the temperature converted to Kelvin is going to be my temperature 1. My pressure 2 is going to be 101.3 kilopascals. My temperature 2 is going to be that converted to Kelvin. Okay, and then I'll substitute all that in there and solve for volume just like you would solve for volume in math class. What about sig figs? I have 4 sig figs here, 2 sig figs here, and only 1 sig fig there. So make sure you round your answer to 1 sig fig because we always round to the least number of significant figures. Okay. Assuming constant temperature, I already told you right off the bat, assuming constant temperature. So that is your constant. So we're only varying pressure and volume, which is Boyle's law. What is the pressure? Okay, inside a balloon that decreased from 0.50 liters at 700 torr to 0.10 liters. So 0.5, that's a volume, that's my starting volume. 700 is my starting pressure. 0.1 liters, that is my ending volume. P1 V1 equals P2 V2. And V2 is what my final temperature is. Now, apples to apples, my volumes are both liters, so that's good. My pressure's in torrs though, and they want the pressure in kilopascals. So I need to convert 700 torr over 1 times my unit conversion. Remember, unknowns go on the top, knowns go on the bottom. My known is torrs, so it goes on the bottom. My unknown is kilopascals. There are 101.3 kilopascals and 760 torrs. So that's 700 times 101.3 divided by 760. And what is that going to give me? That is going to give me only one sig fig. That's going to give me 90 kilopascals to be putting into my problem for pressure 1. Now you might go, I don't have all these conversions written down for pressure. Okay, all the conversions are standard pressures. That's why if you went and memorized those, then you already know what all the standard pressures are because they're what's used for converting. 1 atmosphere is standard pressure. 101.3 kilopascals, standard pressure. 760 torr, standard pressure. 760 millimeters of mercury, standard pressure. So those are all equivalent, so they can be used for your conversion. 1 atmosphere is equal to 101.3 kilopascals, which is equal to 760 torr, which is equal to 760 millimeters of mercury. Those are all equivalent. So I can go from even atmospheres to millimeters of mercury using that same thing. 1 atmosphere is 760 millimeters of mercury because they are all standard pressures. So number 3, make sure you round your answer to 1 sig fig. And number 4, what pressure is exerted by 25 grams of neon at temperature of 25 degrees C if the original temperature was 50 degrees C at 1 atmosphere? All right, so what pressure, that's my ending pressure, is exerted by neon gas at this temperature? So that's my ending temperature. Make sure you convert that to Kelvin. Okay, why do I know it's ending? Because I picked P2 for what pressure, but you could have said what pressure was P1 and 25 was T1, but make sure whatever you do, they match. Your unknown should have a temperature of 25 degrees C converted to Kelvin. The original temperature was 50 degrees C, so that's temperature 1. Make sure you convert to Kelvin. At atmospheres, atmosphere is a pressure, remember? So that is my starting pressure. And so I can leave that there. 25.0 grams of neon. Did I need that? No, because on my gas law triangle, moles are always a constant, which means grams are going to be a constant because it's always one species or one chemical. We're not doing stoics, so we're not changing grams of one thing to another. Okay, but starting soon, yes, you might have to convert from grams to moles to do your problem, just not today. And this answer again is going to be 1 sig fig. Okay, so hopefully that was a good start. Feel free to watch the video again and work through how to set up the problem. If you don't know how to do the math class portion of it, once you've substituted in to whatever the proper equation is, then make sure that you contact somebody to help you, either me for a one-on-one, your math teacher, or some peer that help you go through the math. Number 4, I did not tell you what triangle problems to do. So I want you to work through and try to figure that out yourself. Okay, but always you can email me for a one-on-one.